Today we're going to finish up cellular transport by talking about active transport. So the cell is no longer passive. It's not a passenger sleeping in the back seat and things are moving to where they need to go on their own. Now the cell is actively driving these molecules to their correct destination. It's having to be alert and active and pay attention to what's going on. Active transport is the opposite of passive transport in both of its two major topics. So with active transport, it is going to require the use of energy. We are now using energy to actively force molecules where we want them to go. And it's forcing because now we're moving molecules from an area of low concentration to an area of high concentration. So we are forcing molecules to go in a direction that they don't want to go in because we're not creating equilibrium. We're creating more of a separation. So if you think about the example I gave with 200 students in the classroom, with active transport, we've got 200 students inside the classroom and 2 or 3 students out in the hallway. Well, with active transport, I'm standing at the doorway and I'm grabbing those 2 or 3 students and I'm shoving them into the classroom full of 200 students. They don't want to go in there. There's tons of students in there. They're all crammed up. But I'm forcing them in there. I'm using energy to push them into that room full of students where they don't want to go. Okay, that's the idea behind active transport. So these are going to be molecules that the cell needs a lot of them. And that's why we're forcing them into this area where they're already a high concentration. These are things like amino acids or sugars so that the cell can build the proteins it needs and make the energy that it needs to live its little cellular life. Okay, so we're forcing more and more and more into this area of high concentration because the cell needs these things. Sometimes what we'll call the way that they move in is by using a protein pump. So this is one of those protein channels that are in the plasma membrane, but now these are the ones that they don't stay open all the time because what we're bringing in is so big, they have to open and close behind what they bring in. Now, because this protein is having to change its shape to open and close, it is going to require the use of energy. Do you remember what that energy molecule is called? It acts like the battery. ATP. I remember ATP. And what organelle makes all the ATP? The mitochondria. The mitochondria makes all the ATP. Here's just another image to show you how these things can change shape. So they're proteins, so it's all about shape. So when the correctly shaped molecule locks in and it fits perfectly, then the cell will provide that protein with energy, some ATP, and that burst of energy allows allows the protein to change its shape, okay, closing behind the molecule so nothing else can sneak in and allowing only the one molecule to go in. And then it'll go back to its original shape and wait for another perfectly shaped molecule to come along so it can use ATP to open up again. There are 2 types of active transport based on which direction the molecule is going. So you have endocytosis, endo, one of our prefixes, which means within or inside, and cytosis, referring to the cytoplasm. So endocytosis is when a cell brings molecules inside, inside, and then the opposite, exocytosis, exo, another one of our prefixes, meaning outside or outer. With exocytosis, this is when the cell is going to use energy to make a molecule exit the cell exocytosis, exiting the cell. Here's an example of another way that a cell can do endocytosis. Instead of having a transport protein that opens and closes, it can actually create a little bubble of the plasma membrane that sucks in what it needs. Maybe it's food, and it creates a little bubble, a little package. Do you remember the word for package? Vesicle. So it creates a little vesicle by pinching inwards. That's endocytosis. This same process, you can take a vesicle. So this is most likely going to be waste products that the lysosome has digested up. It can merge with the plasma membrane and spit out all that waste. So exocytosis, because it's exiting this time. So remember, these active transport processes require the use of energy. The cell has to expend energy to do them. And we are going against the concentration gradient. We are forcing molecules into an area of high concentration. Make sure that you can tell me the difference between passive and active transport. Make sure that you can tell the difference between the two and what they're doing and how they're working, as well as be able to tell the different examples of each.